So hello everyone, welcome to my video. Yeah, this time I'm come up with the project video of fine tuning the AI and ML models. This is the most important part as it tends towards the efficiency, performance, cost effectiveness, and specialization. So in our use case, it is of credit card fraud detection that the project video that I last time made. Okay, we will discuss these points later. Let's see the highlights. You can see on the presentation window. ML models versus ANN model. ML models are the models, machine learning models that I have chosen for this use case of credit card versus the artificial network model. So we will see the performances of the individual models. And what is the use case? As I told you, for comparison will be that credit card dataset that is available in Kaggle website. Same, it has historical data of fraud versus not fraud. So comparison of stats will be there. I mean, how efficient our models are, our ML models and our ANN model. Means how much they are able to caught the fraud versus not fraud comparison to the actual fraud versus not fraud. So further fine tuning will be done of models to achieve desired results. If they doesn't met the performance, we will fine tune them. I will demonstrate some general fine tuning parameters or techniques to achieve the desired results. So even the use of stacked model technique will be shown. That is being using different multiple models to get the desired result. And lastly, we will use the ensemble learning also. So all these points will be discussed uh, to get the desired result as per our business problem. Okay. Okay. So yeah, and I have highlighted the aim also. That first and final and only aim is to make the model efficient. Okay. So these are the points for the benefits of fine-tuned model. So we can see that and efficiency means that pre-trained model saves time and computational resources. And we can see performance also. It enhances accuracies as per our business requirements, as we can achieve desired training and testing accuracy, and then we will save that model to test on new data. So in our use case of credit card fraud detection, it can help in achieving higher precision and recall rates. We will discuss the precision and recall terms later. So also cost effectiveness is there, reduces the need of large amount of level data, hence computing power is saved. You can also the highlighted point is specialization, which means that fine-tuned models are specialists in their own task. They are more efficient than the generalized models like ChatGPT or else that are available in the market, because they are specialized in the particular uh, task. Okay. So here we are in Kaggle.com. Same last time we will use the credit card fraud detection dataset. As you can see, you just have to go to Kaggle.com and that you have to type credit card fraud detection. So see, this is the same dataset that I used in last project of credit card fraud detection. You can see here, if I select view more, you can see here it is written over here also that this dataset contains 492 fraud cases out of this much transactions. Okay, and you can see here, even if I go below, so you can see here the data has been transformed uh, according to PCA. They have applied PCA and they have transformed the data because of they cannot share the real information. We will use the same data. Now I will show you the same data in Excel file. Okay, so here we are in that Excel file. You can see that is the credit card Excel file same. I will show you. Just we will go to the class. So this is the column name. I mean having the fraud versus not fraud. If I select one, then it should be 492. You can see here in left of your window 492. So yeah. This is the same file we will use. I will clear the filter now. You can see now. If I see the transaction, you can see here the count is similar to the Kaggle. And okay. So yeah, we will go to the coding screen. Okay, so here we are in our coding screen, and firstly we have to decide that which ML models to take to predict on the credit card data set that we downloaded from that website Kaggle. Okay, so you can see here I have pasted that credit card.csv path and loaded that to df data frame, and we are training the models on this path, this csv file, I mean dataset credit card with card numbers. So this is the same file that I used in last project also. This is the replica of this credit card csv file, and because we have changed the amount. Let me show you. If I go above in this notebook, you can see here. Okay, yeah. So you can see here we have put that credit card CSV file dataset into DF data frame. Then we have changed the transaction amounts, and we added credit card numbers last time, random numbers. We did this because I want to generate alerts, and we need some entity like mobile number or credit card number. So in our use case, we need credit card numbers on which alert should be generated. So no problem. The amount will be changed, and the data is the replica data. So we will train the models on that only, and I will show you which three models we have taken. First one is a random forest classifier. You can see here we have in a defined model over here, a random forest classifier, logistic regression, and then SVC support vector classifier. So I run this code and show you the results and explain all general things, but firstly we will have an idea what these ML models have and how they work and what is their common methodology. So let me show you. Okay, so yeah, random forest algorithm. So what I was telling, the same thing is here. Training set is divided into different training samples, training data 1 to up to n, and these decision trees are also from 1 to n. Remember, the higher number of trees, then the greater chances of accuracy, and the problem of overfitting will also be minimized. So yeah, I told you that in case of regression, averaging will use, and in our classification voting will be used, and the prediction file, then the final prediction will come as a output. So let me show you in our use case of credit card fraud detection how okay. So here we are on presentation screen. You can see I have made a very simple and easy explanation of random first model. So here, as we know, I have told you that whenever first our random first model is being trained, and after training, what is this data? This is a new incoming data, and we have to, like in our for this use case, credit card file. So we will make prediction on that. So it will be done by these decision trees. You can see here, these all in circle are decision trees that have the questions, and the data will be divided into different samples. This is just for representation. I have given single question to a single decision tree, but yeah, they have all the sets of the questions. I mean all the sets of all the features that I told you, like IP address, location, or merchant. So they will check for the similar pattern, like I will explain now that what first decision tree is asking is transaction amount similar to previous transaction, yes or no. Okay, So if the transaction is similar to previous transaction, no is the answer. Then what it is doing, it is classifying it as fraud. Okay, similarly, does the time of transaction similar to previous, yes or no? Yes, so not fraud. It also have fraud probabilities, and in every algorithm, please remember that 0.50, I mean 0.5 means 50% is the threshold by default. You can change it as per your business problem. So what happened now, that third decision tree is asking, does the IP address similar to previous, yes or no? So if it is no, then it is going to be a fraud. So the now when the decisions are all done, then there will be voting majority will be taken, like in this case, simple case, two frauds versus one not fraud, so the prediction output will be fraud. So yeah, so this is how this random forest works, but it has a high count of decision trees, and it segregate easily the fraud transaction between the all transaction. So that's why that is the beauty of the random forest model. Okay, we will now move. Okay, so yeah, this was a very simple and easy presentation of transaction verification done by random forest model. Now we will move to our next model, that is logistic regression model. Okay, so here we are. You please look at the and please check that this is a simple representation of y-axis and x-axis, and what a logistic regression do, it creates a decision boundary which is effective for classification. Classification means binary classification 0 1, true false, fraud not fraud. So okay, so I will explain in very easy and simple manner now. So as we all know, and it is written in black, you can see the equation of a straight line, y is equal to mx plus c. So what linear regression do, it generates in our use case of credit card fraud detection, it will generate probability for each transaction, but we need to classify into fraud and not fraud. So we are using logistic regression, and we will now see how it works. Okay, so as we move to next slide now, you can see here the y-axis is having probability starting from 0, then 0.2, then 0.5, then 0.7, and then up to 100%. Okay, and you can see this blue line over here, which is cutting x-axis and y-axis below. So this line is our straight line. So basically we have data, and our straight line falls over here. So and this x-axis after 0, you can see here the where it is cutting the x-axis, the $1,000, then $1,500 and $2,000. This is the income bar. So okay, so what we are doing over here, so we are decoding and we are predicting the probability to purchase a flat in US. This is our business problem. So we have to make predictions. So I can say now, as looking at this graph and this straight line where it is cutting the x and y axis, I can say that if salary is $1,000, if salary is $1,000, then probability is 0. Okay, so this is straightly you can see $1,000 here, and what is the probability here? 0. So I can say whenever the salary is $1,000, the probability is 0. Okay. Okay, so moving to next slides, as I was telling you that we come to know that whenever the income or salary of any individual is $1,000 or below $1,000, so there is zero probability that they can buy the flat. So because as a if someone is earning less than $1,000, be it $500 or $700, uh, do you think is it a logical approach that or makes sense that we have to think that we have to go towards the minus probability? So yeah, any amount less than $1,000 or equal to $1,000, it means that it has a probability of zero. Similarly, I mean this the flat probability is zero at this value, and it means uh, now like this only. If we see the graph and join the coordinates, let me go to the next slide. You will very easily understand. Now here you can see here what happened over here. We have joined these coordinates, you can see in red. Okay, and further your way finding the boundaries. So here it cuts on $2,000. So what is the analysis now? That at $2,000, the probability of purchasing a flat is 100%. Right? That's what our data is showing us. That's what our data is telling us. Okay. So we have concluded till now that at $1,000 or less the probability is zero, and at $2,000 or more, the probability is 100%. Okay, very good. I mean, anyone would have understand this logic. Now we will move. Okay. So have you noticed what is being happened here? Uh, the probability, you can see the straight line, the equation of a straight line, that this one from minus infinity to infinity, the probabilities between minus infinity to plus infinity is being converted into 0 to 1. We have done that. Have you noticed? So because you can also say between 0 to 1 means in data science 0 to 100, because 0 0.2 stand for 20, similarly 0 0.5 stand for 50, 70, and then 100%. So what we have done, we have converted them to from minus infinity to infinity. Now it is between 0 to 1. As I told you that we got our 0% at $1,000 or less. Similarly, we got our 100% above or equal to $2,000. So in this way, we can say that we have converted the minus infinity to infinity probability between 0 to 1. Oh, wow. So we are getting more towards the classification. So this is how we will classify our business problem. Okay. Let me move ahead. Okay, so as I was stating that we have successfully converted probabilities from minus infinity to infinity between 0 to 1, as we have our 0 at $1,000 and we have our 1 at $2,000. So we have our probability for 0% to 100% in this area. You can see this triangle here, here, and here. Okay, $1,000 till $2,000. So this is important now. Please pay attention as we are moving ahead in this logistic regression methodology. So now, if a guy or a girl who is having $1,000 or less, they have zero probability, and a guy or girl who has $2,000 or more salary or income can buy 100% can buy a flat in US. But if somebody has a salary of $1,500, okay, this one you can see here, $1,500, then what? Okay, we will see. Yeah, we will see, we can see in this slide now. When I join this, okay, so if I join the coordinates, the probability becomes 0.5. Okay, so this is this guy or girl is not at a good position because the probability is 50%, right? So either they can ask for credit from bank, friend, or near or dear ones, or the simple another thing is that they will not be able to buy it. Okay, so this becomes our threshold now. Okay, so this become our threshold at this point, of where $1,500 value is there, when somebody can buy. So this become our threshold. This is very important. That's why I was telling you. This is the border. This is the border point. Okay, here we have to judge. And now, and looking at the data, I can say that, okay, so if someone has a salary or income less than $1,500, then the probability is zero. Okay, and if someone has salary greater than $1,500, then probability is one. Okay, so this becomes our threshold point. Fine. So this is very crucial in your data set. You have to find a threshold. I mean, to your data model and your data, you have to decide a threshold where you have to segregate between 0 and 1, true, false, in our case, fraud, not fraud. So now again, have you noticed what has happened here? Just think what is happened here. I will explain you. Asking you, have you noticed what happened here? So I will tell you now. Again, firstly, what we did, you can see in the presentation window, we have converted the probabilities from minus 15 to plus infinity, between 0 to 100%. Now, from 0 to 100 probability, now we have converted these probabilities again, and we have converted, as you can see on the presentation window, from 0 to 100%. Now we have converted to 0 or 1. Okay, it means we have converted this linear regression model into classification model. Okay, 0 or 1, it means if the salary is 1,500 or less, then 0, it means not able to buy. If the salary is more than $1,500, the person is able to buy a flat in US. So have you noticed what we have done? We have just solved the business problem of buying a flat in US. Okay, all right. Let me explain further. Okay, so yeah, as I was telling you, we have successfully converted the probabilities from minus infinity to plus infinity, firstly to 0 to 100%, and then between then 0 or 1. And we can further say that, now, like in our credit card fraud detection project, we can classify the transaction between 0 or 1, 0 or 1, or true or false, and similarly in our project, fraud or not fraud. So yeah, this is all about logistic regression. Okay, so let's discuss about support vector classifier. So it is also a classifier, and what it does, it creates a flat boundary called hyperplane between the classes, so that classification can be done easily. You can see here, between these squares and circles, this hyperplane is being formed. So it creates this hyperplane so that you can see there the squares are on one side and circles are on other side. So easily classification can be done, and it is very famous for classification. As you can see here, squares are one class and circles are second class. in our case, fraud or not fraud. But it doesn't mean that it cannot do multi classes classification. You can see also in second pic, I mean in second diagram, you can see also three dimensionally it has segregated the three classes as well. So it is used for multi classes as well. Okay. And last time I told you that for a small data set SVC is recommendable, and for large data set linear SVC model is recommendable. Okay, let's go to the next slide. Okay, so as I was discussing, yeah, so we placed a hyperplane between these circles and the squares in such a way that there should be a clear classification. Okay, now we will try to, we have tried A, B, C, three hyperplanes. We have tried. So you have to tell me which hyperplane is best. Just give a thought. So what is the best hyperplane in this picture? A, B, or C? So I will tell you now. You can see here A and C hyperplane is very close to data. A is very close to this square. Similarly, C is very close to this circle. So what happens, whenever while placing these hyperplanes, A and C are very close to the data. So that's why misclassification chances are more. So it should be hyperplane should be placed in such a way like B, that the clear classification should be done. I mean proper classification should be done. And this placing B in a right area is called the best fit. Okay. And so this is the proper classification, and the model should be right fitted. So this is was all about the support vector classifier. I believe that you have a very good idea now between all three models: random forest, logistic regression, and the support vector classifier. We will use this on our credit card data set, as we have older predictions. So we will see how these models will capture the frauds and not frauds, and whether they are very good to match with the historical outcome. Okay. So before that, I will also show the business objectives and constant for the our business problem of this fine tuning. Okay. Okay, so here we are on our defining our business problems. Okay, so as in earlier videos, I have told that whenever we have any business problem, so for a clear business understanding, we have to segregate between business objectives and business constraints. So let's have a quick overview. What is our business problem here? That we have to fine tune the ANN model to achieve 90 or above training and testing accuracies. So, what will be our business objectives and constraints as per our business problems? Okay, so you can see here the business objectives are identify previous fraud patterns. That is must. I mean, objectives means these should be this has to be followed. Maximize true positives, okay, and true negatives. Okay, so maximize true positives and true negative means we have to our model should give clear cut fraud and not fraud, because we don't need raw predictions. It means for both fraud and not fraud, we don't need wrong predictions to be high. So we have to maximize true positives and true negatives. I will discuss in briefly in nextly. Then we have maximize precision and recall rate. So precision and recall rate is most important. Recall rate is that how many frauds and not frauds that were actual, and our model count has been matched with them. Okay, so similarly precision is that how much fraud cases, for example, how much fraud cases our model has disposed, and how much are correct. Okay, so it should also be high, and recall rate should also be high. So that's why maximize it. Minimize false positive and false negative. You can understand now. So we don't want wrong predictions. So which is the business constant that should not be compromised? That minimize false positive and false negatives. Our prediction should not be wrong. This is the one objective, which become a constant, that it should not be compromised at any level. So maximized true positive and true negative is directly proportional to minimize false positive and false negative. Whenever predictions are high for both classes, fraud and not fraud, automatically the wrong predictions will be become less. Okay, so here we are on our presentation screen where we'll discuss the confusion matrix and classification report in detail, as I was stating earlier. So here, please, see on your right hand side that this white screen is having the stats. This is how the results are being displayed in the end of the code to check how model has performed. So you can see under it has been written confusion matrix and the stats are there. So I have highlighted with marker. 486 are true positives. Similarly, 88 are false positives. 284227 is true negatives, and 6 is our false negatives. So what it means, I will tell you in detail now. So you can see here, firstly, you can see here in the right hand side, support is there in the end. You can see what that support means. Support means that this value and this value 492 is this total count that is the data set is having. So in our data set, 0 stands for not fraud and 1 stand for fraud. I have also highlighted this marker. So 284315 in the end is saying that these are the actual not fraud cases uh, that is there, and 492 are the actual fraud cases that are there. So our data model, whichever model, random forest, SVC or logistic regression, has to match with these stats: 492 fraud cases and 284315 not fraud cases. Okay, so 486 are disposed as true positives by our model. I'm taking as a simple example to explain this matrix. So what it means, true positives, it means that the fraud transactions that are correctly predicted. Means out of 492 of the previous fraud cases, actual 486 are being captured correctly. Okay, okay. Then we will discuss these 88 count as false positive. So 88 cases that are being disposed as fraud are not fraud. So that's why they are false positive. So yeah, it should be minimized. That we have to minimize this. This is was our business constant as well. Similarly, what is true negative? That not fraud cases, not for transactions in our use case, correctly predicted. So 284227, you know out of 284315 are correctly predicted as not fraud, just 6 are wrongly predicted. These our model says this is not fraud, but they were fraud, so these are our false negatives. Negatives means not fraud, which becomes false, so false negatives. So now we have given you a clear understanding. Let's discuss about precision and recall here. Also in the right hand side in the white screen, you can see precision and recall. Okay, so let's discuss about precision for both fraud and not fraud. So you can see here what is precision. I mean, for not fraud, it's 0.85 means 85%. So this is the fraud cases that are disposed by our model and are actually fraudulent. So 80 out of 100%, 85% are correct. So it means still 15% are wrong. Means that this percentage is 88. Okay, and I will also show you the formula later for this. And what is recall here? 0.99. Oh my god, 99%. You can you believe it? I'm in bingo on target. It means that data our model was able to find 99% of the fraud cases. Means out of 492, 486 matched. So similarly, you can say for not fraud cases, you can see precision and recall rate are just 100%. Why? Because you can see here our true negative count is 284227 out of 284315. So the precision recall is become 100%. It might be because system has rounded off. It should be, it must be 99.95 or 99.99, but because it has very less amount of false negatives, just six are wrong when system dispose the transaction as not fraud. Okay, so let's now I will show you how we will calculate all this. Okay, so here we are. We will calculate now. So what is the formula for precision is equal to true positive divided by true positive plus false positive. So we will add first true positive plus false positive, that is here 486 plus 88. Okay, so let's do it. 486 plus 88, 574. Okay, so we have to divide true positives by this sum. So true positive is 486. 486 divided by 574. 486 divided by 574. 0.84. I told you that it will round, so it will become 0.85. Okay, very good. Okay, now we will clear this. We will calculate recall is equal to true positive divided by true positive plus false negative. Similarly, what is true positive? 486. What are our false negatives? That are 6. So 486 plus 6. 486 plus 6. This is simple. 492. And we have to divide this true positive by this sum. So 486 divided by 492. I will again clear this. 486 divided by 492. 0.98. The number is equal to or greater than 5, so the second decimal will add up, then it will become 99. So yeah, 0.99 something. So similarly f1 score also we can calculate. It is precision into recall divided by precision plus recall. Okay, so I will just tell you what about the accuracies and this f1 score. You can see here f1 score is the average of precision recall. So balances precision recall. It should also be high. In our case, it is 0.91%. So it's good. And similarly, you can see in the last ROC AUC score, it's 0.998 means 99.98. So a high score indicates good separation between positive and negative class. So these are the states. Basically, you have to understand that precision recall should be high as per your business problem, and it should be closely close to each other. Minimum difference should be between 5%. So okay, so we will now further go and run the codes and see what are the results by our ML model and then with our ANN model. Are we on coding screen? So let me show you. Okay, so what I have done is I have already saved the model files in the form of pickle file format. You can see here. I just have to load this logistic regression model and in model LR. Similarly, as with model is there, it will be loaded in this variable model SVM. Then simply best random forest model will be loaded into this. So and we will make prediction on same credit card data set. This is the path. Okay, so this is the common practice. As once your model is trained and tested, then you can save it, and then we can use on any data set. Okay, it's a best practice to save the model. So what I will do, I will just run the code in which I have already loaded. I have already saved the model files like this I have told you, and this will be loaded and prediction will be made on the credit card dataset. Let me just run this code. Okay, so I have just run this code. It will run. The system is little bit occupied, but you can see, yeah. So the all predictions are gone. It means it has started running and it will give the results in a few moments. You can see here this kernel becomes black. It says it's busy. Okay, all right, and you can see the time bar over here. Also, it's running. It means this cell having code is running now. Let's wait and watch the results. This is a live scenario that I am showing you with all three models. We'll make predictions and we will check how correctly they have identified the fraud and not fraud cases transactions, I mean. Okay. Okay, so you can see, wow, we have the results with us, and you can see confusion matrix has been built for random forest. Oh wow, what can you see? Can you believe it? 98 and 97 is the precision recall rate. It means the, as I told you, 97% cases has been matched with the earlier fraud cases. It means for 76 cases is our true positives that has been matched with the last previous fraud cases of 492, and even you can say that precision is 98%. It means we have very less false positive. You can see over here only 8 is the count, and 98, 97. This is absolutely out of the box. I mean, this is excellent performance by random forest. I told you already that it's a ensemble method, and the lot of decision trees are used, so that's why they are able to find the pattern, and they have done it. But let's see about the confusion matrix for logistic regression. You can see here precision rate is quite good, 88, but recall rate is 62. But our requirement is above 90, it has underperformed. Though recall rate is less, but 88% it means for false positive is only 12%. So still, random forest is the one, and still we are waiting for the third one. That is our support vector classifier. The results are yet to come because code is still running. You can see here. As you can see on presentation window, like for random forest classifier, you can take class weight is equal to balanced and random state is equal to 42. You can use this class weight is equal to balance in other two model as well, in logistic regression as well and SVC as well. So what it means? It means that model will give importance to minority class because in is the credit card data set, it is highly imbalanced. I will show you. Okay, so you can see here only 492 cases are fraud and 284315 are not fraud. You can see in right side of your window in white screen, and out of 284380 seven transaction, fraud cases are very less. It is no. So when this happens, when while training model doesn't model got overfit, like in our cases, or underfit. So but it has not affected the results of our random forest. Why? Because I already told you it take a number of decision trees, and it doesn't affect the imbalanced data, doesn't affect the decision trees. That's why they are very good in this use case of credit card fraud detection. So but this data set is highly imbalanced. Okay, so you can, if I go back to previous screen, so you can see here resampling techniques like SMOT, synthetic minority, and ADSN can be used to balance the dataset by generating synthetic sample for minority class. You can always have to use the synthetic data, and it will help improve the efficiency. Because I told you in first slide itself, the first and final aim is to make our model effective. Okay. Similarly, what random state is equal to 42 means that, it will ensure that if you run the same code again and again, the same data multiple times, if you run the same code with same data, then the same results will be there. Okay, so it's a common practice to use this random state. Again, if you want to take max iter is equal to 1000, like we did, like here shown in for logistic regression. It means that, it will go, if loss function reaches a, it will check for the loss function. If it reaches a minimum value before reaching this much iteration 1000, so it will stop early. Okay, so it means there is a loss function also that model will check for. If it checks that the loss function is only 1%, 2%, 3%, and before reaching this limit, it will stop, because it will know that, we have already uh, found the best results. And it will check for every iteration what is the best result in last 3 4 5 iterations, like this only. So, and when you take SVC, probability is equal to true, it means that, you are this is you are using internally that cross validation method will be activated, and it will check for the probabilities instead of just class. I mean, just for looking for a fraud or not fraud class, it will look for the general possibility probabilities. So these are some general fine tuning methods. But we have already got satisfied by the random forest model, and now we will go for ANN model, and we are basic purpose is to outperform the performance of random forest. Okay, so I will show you. We will check that how ANN model will perform. But firstly, I will show you the last video in which what was the training and testing accuracy. You can see here. Okay, if I play this, and when the accuracy is higher, so it will. So you can see here training accuracy 99% something, testing accuracy 99% something. Even yeah, if I show you the, okay, if I little bit forward this, you can see here too. In the PPT of that video is showing 99% something training accuracy, testing accuracy. Why? Because this ANN model in last project was trained on synthetic data. Okay, using SMOT, I have created synthetic data, so that's why the model was giving so much high training and testing accuracy. Okay, we will see how it will perform on this credit card dataset. I don't know how this part was missed, but we have to show this to the audience. Okay. Okay, so just check that I will use the same model file. This one, my model CC2 that I last time used on that project. Okay, okay. Yeah, so just for demonstration, I showed you that is the same model file. Okay, so here we are on coding screen. So you can see here I have selected model file, that one only, cc2.h5. And what we are doing, we are loading the data frame, same credit card data frame you can see here. and we I have given the path, and again transform the data and make prediction. But what we are doing over here, we are taking the default threshold as 0 0.5, which is by default in every model. And I will tell you what is the importance of this. Okay, so firstly we will check what is the outcome with threshold 0 0.5. Means if a model will predict the probabilities, then when we classify them as fraud and not fraud, the transactions above then 0 0.5 means 50% probability will be fraud, and less than that will be not fraud. Okay, so I will hit the run button now, and the code will run and give the same confusion metrics and classification report as we checked for random forest. So it started running. You can see here it's a live scenario. Kernel got busy, and even the time bar is there. And I have just placed the confusion matrix or random forest over this code. You can see here 98 97 is the precision and recall rate. So okay, we will see how this model of last project that I made will work with a threshold of 0 0.5. Just running. See, the model is compiled, the loaded model, and the prediction will be made and showed within a few seconds or a moment. It's a live scenario. Oh, okay. So, wow, we can hear this live now. The last results for support vector machine is now here. Okay. So I told you, yeah, it took ample time, because I told you for large data sets, SVM support vector classifier is not, good fit. You can use linear SVC, but I have already trained and saved the model file. That's why I have used. So we can now interpret the results. See, I told you random forest 98 97 best model, excellent results, outperformed every other model. See, 98% precision, 97% recall, 476 out of 492 cases correctly predicted, just 8 wrong results. And for not fraud cases, 284307 out of 284315 correctly predicted, only 16 wrong. So when we look at logistic regression, you can see 88% precision rate and recall rate is 62. So you can say that it has poorly performed. You can see here only 306 cases are being recalled out of 492, and even it means even 12% is also the false positive rate. So this is not expected. We are looking for at least above 90. So see, you will similarly see confusion metrics for support vector machine. I mean support vector classifier. In our case, we have taken. So it has very poorly performed. Even though recall rate is 95%, you can see, but precision rate is only 45%. See, 469 has been matched with the 492 fraud cases, but can you believe it? 578 are false positive. They have disposed as fraud, but they are not fraud. That's why the recall rate is above. So we need, I told you, we need precision recall to be balanced nearby 2 3%. It's okay. Like here in random forest 98 97, just 1% difference. And we this is our best model. So we don't have to look for these other two models, and we don't have to fine tune the random forest model because it have given extraordinary results. I told you as an ensemble method, multiple decision trees are used, but still I will show you some fine tuning parameters, general fine tuning parameters. The parameters are much more. You can run on GPUs, TPUs. There are n number of configuration you can do over there. So wow, you can see here this one 8901. So the code has started making predictions, and just when this uh, will be completed, and it will publish the classification confusion matrix and classification report. It is just the estimated time that is being running. per step. Okay, so we are very close now. Just in a few seconds, we will show you the predictions and results for the same credit card data set. Okay, so here are the results. Okay, all right. So you can see here again, 97 is the recall rate, but precision rate is very bad, 57%. I told you because it is a lot of false positive, 363. So it means precision rate is 57. It means opposite of that minus 100 minus 57 43 something is percent 43% is false positive. So the model has performed badly. It means there it is usually I mean predicting more fraud cases, rather than not fraud, and it is making mistakes in making in recognizing the fraud pattern. So that's why because I have taken the threshold of 0.5, means 50%. And what I told you, just I told you 2 3 minutes back before running this code, that the model was this model. My model CC2 was trained on synthetic data, so it has very high accuracy of we showed the accuracy of 99% something, more than 99%. So what we have to do, this is where we have to give the threshold as per our testing and training accuracy. If I make this 0.99 or just 5% more, it becomes 99.50. Then what happen? I just run the code now. Okay, just wait and watch. You see the code has been running, and you can see here again 8901 steps will be taken. So and the predictions and the results will be in front of you. It is again running live. Just we have modified the threshold as per our models training and testing accuracy that we have watched earlier. And this is where when you have to adjust the thresholds as per your model performance. This is the main fine tuning. So firstly I told you the data should be enough. If not, create synthetic data, either by mode, either by GAN models, and then you have to decide the threshold. Okay, it will just publish the results. Please don't angry on me. It is just coming. Okay. All right. Wow, what a beauty. See, the recall rate is 96% and precision has increased. You can see here from 53 something, I don't know what it was. It has gone towards 74. Okay. So this is still we know that we have to improve this. We have to improve this because we have to beat the random forest model, which is there 98, 97 precision recall rate, outstanding extraordinary results. So no, bear with me. I will tell you how to fine tune this. I will show you. These ANN models are neural networks. I mean, are Firstly, I will tell you that random forest is just an algorithm. It is based on decision trees, and these ANN models, they are neural networks. They will mimic like human brain, so they will learn from the data. They are much capable. They are very much capable. I mean, they are capable. Their capability is enormous. Okay, so we will see. So this fine-tuned model is the simple that you can see here. My model CC2 I have taken. Same model loaded that, and what we have done, optimizer Adam learning late this one, and loss is binary. These are some metrics that we have to do to fine tune the model, and again we will fine tune on that synthetic data. So we will again run that this code. I mean, I have already ran that, and I have already saved in this model file, fine tune model.keras. Okay, and even fine tuning again that with another thing with weights and all, and running on different epochs, and then I have saved it on fine tune model 2. So we will see the efficiency of these two model fine tune model also, and then we will then we will come to a conclusion. Okay. Okay, so last time we have these results. You can see 74 precision rate, 96 recall rate. Okay, we will use a fine-tuned model. As I told you, I already have fine-tuned model files over here. I will use that, but before that, I will tell you. There is one model also that is also CC4. My model CC4. This is also an ANN model, artificial neural network model. But in this model, I have given data of that similar data that given to random forest logistic regression and other SVC model. So the thing is that ANN model I have fine tuned also, but you can just by fine tuning the ANN model, you can just have 2-3% you can increase the precision or recall rate, but initially you have to feed them more data to your NN model, because these models will are very extremely good in finding the similarities, and but you need to give them more data. So they are like hungry beasts of knowledge, but you have to give them enough data so that they can differentiate. I will show you. This model is has been trained on same data of that random forest model, that the same data, I mean, that random forest model and other models were having the same data was given it to the this ANN model to be trained. So well, let's hit it now, this code. I have changed the threshold because I know the threshold of this data model, that you something you have to decide as per training and testing accuracies. So I have given threshold of 0.72 means 72%. So now I will hit the run button. You can see now code has started running. The bar and also the kernel is being occupied, and compiled model is loaded. I mean, yeah, model is loaded, and it will be compiled by making the prediction on the credit card data, the same data set that we are using on every ANN model. But the thing is that I already told you that data is very very limited in this criteria. So let's see what are the results, because those models earlier and fine-tuned models are trained on synthetic data, which is uh, you know 3-4 times. So this should be in your mind always, that whenever you will your model will fall flat at some accuracies, and even after fine tuning, uh, you are not able to increase the precision and recall rate, then you should think about the synthetic data. Okay, so prediction will come anytime now. Just wait and watch. Oh wow, the results have come. Okay, so see what is precision recall rate. 80%, 80%. Yeah, it means it is balanced. Even though the same data in which random forest and other models were trained, the ANN model is able to find 80% precision recall and recall rate both. 392 cases out of 492 cases are correctly identified, but there are false positives. I mean 10% false positives are there still, which we have to reduce, which is our main objective. So I was telling you that their model will fall flat if it doesn't have the required data to train. So you should always increase it. So yeah, this was just to tell you about the fine tuning, methodology. So now I will use another model, fine tune model, uh, that I already showed you earlier. That I have fine tuned some weights and even use other techniques also. So firstly, I will use this, and I will use the again the high threshold, because they are trained on synthetic data and their thresholds are very high. I mean, they are able to segregate. They are much capable of finding this much probability to the transactions, credit card transaction file with the trained data. They are finding so much of probability that they are able to judge that 99 more than 99% chances are there that this transaction is fraud. So I will hit the run button now. And remember last time our that model, CC2 model, that was our that last project model have given 74 and 96 precision recall rate. This time we will check with this fine tuned model how far it has been fine tuned from 74 precision rate and 96 recall rate. Okay, so I have hit the button. The code has started running. You can see here again, same time bar and kernel is occupied. Okay, so you can see that the steps are being running to complete the prediction and then show the results. Remember 7496 was the last, same model, but this is fine tuned model. So how much it has increased? Just wait, don't angry on me. These things take time. This is totally live scenario, and just because I believe that the audience should know that I'm not making this up. In the earlier in other video also, you can just search on YouTube about the credit card fraud detection. They have shown another models also, but all of them have just shown accuracies. But I somehow forgot in last project, but I am showing the actual predictions by our ML and ANN models and comparing it with the real fraud versus not fraud cases. So this has not been done by any of them, and somehow I am doing it for the audience. Okay, so this model is just about to give the results. Okay, so here are the results. Okay, wow. So the confusion matrix is built and classing report is also published. You can see what is the precision rate, 85 and 99. So yeah, oh, wow, what a beauty. From 74 it has been increased to 85. Okay, and 96 to 99. Oh my god, recall rate is 99%. It means 486 cases has been found out of 492 fraud cases, but still it's a long way to go, because 88 false positives are there. I mean, still 85 is the precision rate, then 15% is the this fraud positive, false positive. So we have to reduce that. We have to outperform the random forest model, which results I have just pasted over here. You can see here 98, 97. I mean 476 six it has found from 492. We have to beat this, and we have to beat this other stats also. Okay, we will not give up. And okay, so you can see here the confusion metrics have been populated. And okay, so we are stuck here again. Fine-tuned model have the same results like 85, 99 precision recall. We want to beat more, so we are stuck here with fine-tuned model 1, and again now with fine-tuned model 2. We are not able to go over 90, even though recall rate is achieved, but due to precision rate stuck at 85 something. We can't give up at this point. So what we will have as per PPT, I will show you ensemble. We will use ensemble learning. I will show you, just wait. Okay, so this is the PPT. And on the presentation I told you that fine tuning, we have reached this point for the fine tuning, and then we will use of stacked model technique, which is part of ensemble learning. So this is the last part. Okay, let's just go to that. Okay, so here we are in types of ensemble learning. As I stated earlier, bagging, boosting, and stacking. But we will use stacking and basic ensemble learning first, then stacking. So let me go to basic ensemble techniques. You can see in the presentation window, voting and averaging we will use, and then after that we will use stacking. Yeah, okay. So I will tell you what stacking is. We will use base models, and you can base model can be either any base model, and then a final model which will learn from the prediction of these base models. And it will give weight to much good prediction, and then will classify the each transaction in our use case of credit card fraud detection. Okay, let's go to the code. Okay, so here we are in coding screen. As you can see that averaging and voting will be performed as I stated earlier. So similarly, same credit card file is there, but please pay attention over here. See model 1, but we are loading that our model from last project, same my model CC2 file that is being trained on synthetic data, and model 2 is our now fine-tuned model, because our both fine-tuned model 1 and 2 are having same result. So you can load either any one of them. So okay, so model 1, this file, model 2, fine-tuned model. And what will we do? First we will do averaging, and averaging will be done. You can see here the prediction of model 1 plus prediction of model 2 divided by 2, simple averaging formula. Then voting will be done. Okay, and for voting you can see here voting prediction 1, voting prediction 2, but we have given threshold, the best threshold that we already have. And then the voting formula will be applied. You can see here predictions are added and divided by 2. uh, initial votings for 1 and 2, and then it will perform the formula. Okay, so let me run this code, and we will see how much time it will take. All right, I'm just running this code. Okay, so you can see I have already run this code. Soon it will start running. Yeah, you can see here the kernel got busy and time bar is showing over here. Okay, let's wait and watch for the results. So as I told you, this is the basic ensemble learning method: averaging and voting. After that, we will perform stacking. Okay, so we can see here the second model, is also compiled the loaded model, and the steps are being taken to make the prediction, and then simply the calculation techniques will be used for averaging and voting. Just we are about to have results. The two models, one's prediction has been done and saved, and second is just about to make, and then the formulas will take place of averaging and voting. I told you this is the basic ensemble learning methods. So you can see, oh wow, I told you na, that will come in just a moment. Okay, so you can see here 8496 is the precision recall, 471 is averaging classifier has produced, and 89 are still we are struggling with our false positives. Similarly, only similar results with voting. So averaging and voting have not benefited us, so we have to try stacking now. Got, see, averaging and voting have not worked. So last option, we have stacking, and we will see what stacking will do. I have already given the overview of stacking. Let's go to stacking. Okay, so here we are, and this is our last part. We will use stacking. Firstly, we have to build the model and for stacking. So yeah, why stacking? I told you I have already used stacking in customer chain project lastly, and it has given significant results more than bagging and boosting, that are also ensemble methods. And I have discussed with many data scientists. They have told me that stacking always gives higher results because it always takes the strengths of the base models, and then final model is trained on the predictions of the base models, and then it will further classify, like in our credit card use case, fraud and not fraud. So I will just explain now. What happening here is we are we have already created a build a model. It is just ANN model. You can see model is equal to sequential. So it is our first input layer, and then dense layer. It means this is our hidden layer with 100 neurons dimensions that we have to give the features. Activation is relu. This is something that you can decide, and our output layer is this one with one neuron. It means uh, it will give probability of from 0 to 1. Why? Because activation is sigmoid. For each transaction it will produce the probability between 0 to 100. And uh, so here what I have done, I have not used any previous ANN model 1, model 2. I am using fresh models, and they both are the ANN models, and with the same configuration. You can see epochs 50 each, batch size but 32 each, verbose is equal to 0. So and the final model, these are our model 1 and model 2 is our NN models, and our final model is logistic regression, because we need a classifier to use the predictions of our base models, And I have already explained logistic regression. It is a simple yet powerful classifier. So you must be asking the why we have taken these similar models when already we have trained models like my model CC2 and find model file. Why? Because you can it have different training dynamics. Two NN models with same architecture uh, can learn the different aspects of data due to different differences in initialization and training order. So you must have heard that two is better than one. So it's something like this, and also the option is of complementary errors, in which two models might make different type of errors. See, model 1 and model 2 both are ANN models. So the model 1 will make some mistake, model 2 will make some mistakes, but when the error is combined, actually, so what happened that the errors will cancel each other out, leading to better overall performance. And logistic regression, I told you, is a simple yet powerful model. So you can see here, final estimator means final model is logistic regression. So it can effectively combine predictions of two base models. So it will simply weight the prediction from each model, giving more importance to more reliable prediction. So you can see here I have already trained the model and saved in a file. Find, you can see here the file name is fine tuned stacking model. So you can see here the training has been done, and even now we will use this file. You can see here in stacked model predictions I have already put this code. Again, fine tuned stacking model file will be used, and we will just make prediction on this credit card file, same file we were doing it before. So we will see. Firstly, we will take the predictions of I mean threshold of 0.5. Okay, I have just put threshold is equal to 0.5. So we will see how this will give the results. Let me hit the run button. Okay. Okay, so you can see here the code has just will has start running. Yeah, the time bar is there and the kernel is occupied. So we will have our predictions and our results soon here with threshold of 0.5 for this stacked model. Okay, so yeah, you can see here the results are here only, and you can see, wow, what a beauty! You can see the precision rate for fraud is 96. Can you believe? And the recall rate is 100%. Why? Why? You can see here 491 cases has been identified as fraud by this stacked model. Out of 492, only one case is left, and we have some false positive, that is 22. And that means only 4% are false positive. Significantly the this performance has been improved. And you can see from last result was, if I go ahead above, you can see averaging has produced 8496, both averaging and voting. And after 84 and 96, our stat model predictions become 96 and 100%. I mean, it's not 100%, 99.99 something, because only one case is not being identified. All 491 other cases are being identified. So can you believe it? I told you stacking works, always works. Okay, let me just apply a custom threshold now. I told you that these ANN models have a very high training and testing accuracies, as I showed you earlier. Why? Because we have given them synthetic data to train upon. So we will use the last threshold, that was 99.5. So I have put threshold is equal to 0.995. Let's just apply this. Okay, so you can see here, yeah, as already the model is built, so it took no time. You can see the we have again improved the performance with reducing the false positive. Earlier it was 22, it become 14 now. Okay, the true positive are same, 495, one is identified, and the rest is same. Just our precision rate from 96 it become 97. Oh wow. So you can see here, uh, we have outperformed the random forest model. That was our goal. If I copy this data of random forest model, if I cut that and paste, okay, okay, here only, yeah. So you can see random forest has given 476 fraud cases out of 492, and our model stack model has produced 491 out of 492. So we have outperformed in terms of true positives, and you can see here only one is wrong for not fraud cases, and for random forest it has wrong cases of 16, not fraud cases that are wrongly identified at fraud is 16. Okay, so yeah, so our goal is achieved. That firstly, we the first and final goal was to make our model effective, efficient. So that has done with the precision rate of 97, and almost 100% is the recall rate. See, I told you we were struggling with the fine tuning the model of our N model, and we used the techniques, and we fine tune them, and then we use ensemble learning also, and with averaging and voting didn't turn in our favor, and then stacking was applied, and we got the desired results. I mean, unexpected. I mean, more than expectation. So in this way, you can fine tune your AN model, and there are also precedence of AN model over ML models. See, these ML models, random forest and all, are just algorithms, but they are learning models. I told you that's why we gave them more data, and they was able to find the similarities, and with the help of not single but double ANN model, and just using their protection and classifying them, we achieve our goal. And one more thing I will tell you, just what is the advancement of these ANN model over ML model. Okay, so I will tell you now what is the advancement of ANN models over the machine learning model, like our random forest model. So you can see here this data. There are some previous fraud patterns in which some feature are there, that is amount, frequency, time frame, and merchant. And this is fraud pattern. So the result was fraud. So like in amount, you can see here. Okay, so some amounts are there in fraud transaction or fraud transaction. So last least amount is $50 something. Similarly, some frequency is there, 20 transaction in 1 hour, 15 transaction in 1 hour, and the least is 14 transaction in 1 hour. Similarly, time frames are there, 1 a.m. to 2 a.m., 2 a.m. to 2:30 a.m. Similarly, some merchants are there in which fraud was happened, ABC, NBY, and all. So what happen if new pattern emerges like this? Some fraudsters start using amount of $49, and the least amount in fraud pattern was $50, and then it is using frequency of 10 transaction in 1 hour. Again, similarly, it is going ahead. It is using the time frame of 3 a.m. to 4 a.m. Merchant is also new. So what happens with random forest? Random forest, as I know, told you before, that they are decision trees. So they will ask what whether the amount is in fraud pattern or not. But because the least amount was $50, this is $49. So no, not fraud. So no, I mean the result outcome is no. Similarly, for this uh, frequency, 10 in 1 hour, there is no, there is not present in the frequency previous patterns. So again no. Similarly, time frame is new, that it is not in previous patterns. So again no. So merchant is also not in fraud patterns. So again no. Why? Because random forests rely on historical patterns. Similarly, no will lead to not fraud for this new pattern, new transaction, I mean. And even if they are, I have only taken four features. You can say that if some more features are there, even if majority of random forest is no, then it will lead to not fraud. But what ANN will do, it will if like our model, it was predicting very high probability, let's say 95%. From 95%, if it check amount is is similar with the previous fraud pattern. If no, then it will just cut -5%. Then again, frequency didn't match -5%. Then again, the time frame didn't match -5%. Then again, merchant is not in fraud database, then -5%. So initially, from 95% to 75%, it will still give the fraud probability. So we can align the second level alert or report, in which we will cover these transactions. So this cannot happen in random forest. That's it from my side. We have now arrived at the end of this project video, and on a very happy note, we are ending it. As we have achieved a very high precision recall rate, and we have achieved our goal, that to make our model, efficient. And we have have outperformed the random forest model. And I told you the advancement of ANN models over ML model. So guys, please take care. So guys and girls, please take care, have fun, and take care. Bye bye. It's Akhil Singh Rawat now signing off.